Okay, effect of pH on solubility. So it says which one is more affected by pH. Well, so it's going to be qualitative, but it should be easy to tell. Both of them are insoluble salts, so they both break up into ions, a slight amount. Now, when we say pH, we're going to talk about the addition of an acid. We could be talking about the addition of a base too, that's possible, but in this case we're just going to be dealing with an acid. So if you have CO, or the carbonate ion, if you added acid, what would happen to it? Well, it would go further on in this equilibrium, and this would be water, liquid. But you say, oh, this guy could keep going. It could continue to react with acid if it was available. So just want to see how far we can go with the addition of an acid. We started with carbonate ion, we changed it to hydrogen carbonate, and now we have carbonic acid. And what you need to be aware of, and this is from 1170, but you might not remember, is that carbonic acid is unstable and it will break up into water and CO2. And there's no return arrow because that gas goes up, and that's an older term. You put that arrow there to indicate that gas has evolved. So the strontium carbonate, the strontium doesn't do anything, but the carbonate can go on for 3 more steps, and then you create CO2. And you may have seen this where you take a acid and any kind of like chalk or a baking powder or baking soda. You don't have so if you took like vinegar and baking soda, it bubbles up. This is the reaction that's going on for the same kind of carbonates that are available, are found in those compounds or in those household items. So and once that gas is formed, it's not going back. That CO2 is not coming back out of the air and going to go back and equilibrate. That's why there's only a forward arrow. Now let's look at strontium sulfate, see what it can do. So it's just a comparison. You can see that there are 4 steps here. For this one we have the sulfate. Well, what can the sulfate do? We know the strontium is not going to do anything. It's positive, so it's not going to be affected by the H3O+. H3O+ comes in, creates hydrogen sulfate, that's stable, and water. So it does about the same thing as the carbonate did. And then the hydrogen sulfate, or the bisulfate, will react with another H3O+ and produces H2SO4 and water. Now this is a strong acid that you've created here. So it's not going to go forward. As soon as this is made, it shifts back. It's completely over to the other side. So this would be, you could put no reaction. Well, so this whole reaction doesn't happen. So the strontium sulfate goes 2 steps. The strontium carbonate goes 4 steps, and it produces a gas, and it continues to go through. So the strontium carbonate is the thing that is more affected by the acid. So that one's pretty obvious. As soon as you see, if you have this, I mean, I also want to see the steps on the reaction, but you know which one wins out anytime you see a carbonate. And I can't have 2 carbonates in here, like calcium carbonate, because they both do the same thing. And it's qualitative. One may go further than the other, but we don't know. We don't know which one, just from a qualitative viewpoint. So there'd only be 1 carbonate, so that would be your 1 hint. Now, how about this one? No carbonates present, but we do the same thing. This AgCl goes to silver ion and chloride ion. The chloride ion looks like it would react with the H3O+. It produces HCl. Whoa, that's a strong acid. We'll finish it up, but it's not going to go forward. It's only going to have this one equilibrium. This one is not going to happen. It lies completely to the left. So this doesn't happen. So you could stop there, because the other one, unless it did the same exact thing, then there wouldn't have been any point to the problem, but might as well go through with it. On the exam, you'd need to show me the reaction. You need to show the steps. Now you can see the Cn minus, and what you must remember from the previous chapter is that it's going to create a weak acid. And that is a true equilibrium. There is a shift this way. So we get a shift. Let me go back to this because I don't think I specified too much. But you have the strontium carbonate. It produces these ions. Then this ion goes on to react, and it keeps going. And by reacting, that means that we've used up some of it from this reaction, this equilibrium, so it shifts to the right. And since this carbonate eventually ends up as CO2, the reaction just keeps rolling along until all of this is gone. This one goes forward, and then the sulfate ion reacts a little bit, so it goes a little bit further than it would. So if you have strontium sulfate on its own, it'll dissolve to a certain degree. But if you have this reaction, if you have an acid, it will go a little bit further, not very much. But this one will go all the way. Will start out with your strontium carbonate on the bottom of the container, and it will completely dissolve. So here, again, we're looking at Le Chatelier's principle. Here this goes forward, and that's it. But here, this second reaction will take away some of the Cn minus and push the reaction forward. If you're getting rid of it, of this ion, turning it into something else, then this reaction has to go forward, which means this will dissolve a little bit more. It won't dissolve as much as a carbonate. The carbonate will dissolve completely if there's enough acid, but this will be pushed forward further than this. So we'd expect that when we put silver cyanide in a solution, a lot of it would lay on the bottom. We add a little bit of acid, or a lot of acid, and a little bit more of it will dissolve. Not very much, but definitely it is more affected than the AgCl.